Hello, everyone. Welcome to the session. My name is Guilherme. If your Portuguese accent is not that good, feel free to call me Gui. I work at Checkout. If you want to know what we do, just go to the booth on the exhibition area. My colleagues will tell you more about us. So, what I want you to talk about with you today is based on the perception that I have that in this industry, we have really good patterns, really good architectures, really good concepts that we try to apply in our day-to-day life. And they are perfectly fine and we love them. The problem usually starts when you try to combine multiple things. And that remember me when a theoretical physical will try to reconcile quantum physics with the classical mechanics, right? So that comes to the grand unified theory of clean architecture. Obviously, this can be fake news. I can promise to unify everyone, but at least I will give my best to do it. So if, like me, you have been in this industry for a long time, or at least you have changed jobs, you have on board multiple people, you have seen many things in code reviews and so on in new projects. And some of those things may have led you to questions like, what the hell is a unit test in this company, right? Or for example, where should I write this test? Is common as well when you have such a long pyramid that no one understands what they should do. Or for example, when you are reviewing a code in an architecture where there's a folder named domain, but no one seems to care and everyone tries to bring everything into application services and so on. Or the worst of all, and this one is really bad, oh, why I didn't invest in Bitcoin early, because that way we'll solve all those problems. We wouldn't care about that. But unfortunately, I'm on your boat as well. I'm not sure what is happening. Okay, maybe I can't approach my laptop. Okay, so what I want to bring you today is my view on how to simplify not only your life as a developer, but for your team as well. And you can do that by delaying a lot of decisions that we try to take too soon, and also to simplify the way that you see tests in your architecture. Okay, so to do that, I want to bring you on the journey, on my personal journey. And as every single good story, it starts with once upon a time. Just because I don't want to say my age, let's say, but once upon a time, I started as a software developer, as a VB.NET developer in ASP.NET Forms. Yeah, you maybe feel the pain of that. And I also worked with a thing that most of you never heard about it, for sure, that is Lotus Notes with a language that was Lotus Script from IBM. So at the time, no one taught me how to do proper coding. I was just fresh out of college. And code behind was my thing. Spaghetti code was the only way to work. And the best thing that I could do was extract code into a commons folder. Many of you have seen that code. Maybe you have seen my code as well. So 1 year later, I decided to join university because I was feeling that there should be a better way to do things. And so I worked 9 to 5 every single day, and by the end of the day, during the night, I would study. And in the university, I was introduced to a thing from 1992 that is the 3-tiered architecture that also led to the famous multi-layered architecture. So on one, you have the client-server database, while on the other one, you have the that application layer, business logic layer, presentation layer. I bet that most of you have seen that in place. But no one told me about one thing that is from 1992 as well, that is the entity control boundary by Ivar Jakobsen. I don't know why no one told me about that. Maybe it would be useful. But the reality is that I was really excited with that multi-layered architecture. I could finally organize my code. I could stop doing all that spaghetti and start building a lot of lasagnas. So I went back to the office and I tried to apply that everywhere. I was becoming a good cook, but as anyone has cooked a lasagna before? Do you know where you start? By the bottom up, right? And if when you get to the top layer and you understand that you forgot an ingredient on the bottom one, you are screwed. It will take a lot of mess to get there. And the same happens with software. So even having a better organization of my source code, I was finding that often we come back to the data application layer to review things. Because when you start with a multi-layered architecture, the first thing that you will do is basically what is the database that I want to use? Basically that. And when you do that, you always use the same, I can assure you. And then you go one step further and you start trying to come up with a database schema, right? Then you move on, you implement your data application layer, and then you move on and you go to your business application layer. And there are some people that say the business logic layer is the most important thing of your application, right? I agree with them. But reality, many of you should know this better than me, is when you are writing code that you discover most of the requirements of an application. You can have the better product team in the world. They will do a lot of investigation in the beginning, but you will find a lot of things as well while you are implementing, especially the business logic layer. So when you find problems there, you need to go back to the database to review sometimes if you start from the bottom up. And I was seeing that happening so commonly, to a point that when we have, for example, we detect that we pick the wrong data type, we just write down that thing, and we expect to have another thing that we discover, and we do that in bulk. So the feedback cycle of a single change was quite high. And that didn't make a lot of sense in a world where we start to have people like Kent Beck talking about extreme programming. Yeah, being really fast, agile, all those kind of things. Even 2 years later, Kent Beck gets together with another people like Martin Fowler, Alistair Cockburn, and so many others, and they came up with Agile Manifesto. And all those things are just about being really fast, discovering things, collaboration, feedback cycles. And I was feeling that this multi-layered architecture was not the way to achieve that. So it should be a better way. And TDD, trying to do TDD with multi-tiered architecture was something that to me didn't work, maybe my fault. But I could try to learn it at the time and I couldn't. And recently, I finally get to manage it after I moved my architecture to a different practice. So all these feedback things, I was not able to get it. And that was causing me a lot of frustration. And then comes 2003, and Eric Evans publishes a book about DDD. How many talks do we have on this conference about DDD? Many, right? One thing from 2003, almost 20 years old. And one thing that it comes to the realization with this book is the importance of that business logic layer that I was telling you. So my end goal is basically one, is how can I start developing my business logic layer without needing to come up with a database first? Luckily, in 2005, Alistair Cockburn was having the same problem that I was having. He was working on a project, and two teams have different responsibilities. One of them was responsible to build the data application layer, let's say, and the other was responsible by the business logic layer. And they couldn't match in a schedule where they could deliver the things in the expected time because one need to go first and the other one only could come after. So Alistair came up with this idea of why don't we have a contract between us? And that led to a really simple thing, that is the realization that all software has an internal and an external side. Okay? On the internal, you will put everything that is really important for you, everything that is special about your application, right? And on the outside is everything else. It's a database, is HTTP, is whatever you want to pick. But as you know, on that internal that it names as core application, you need to communicate with the outside world. Yeah, there's no point of having code if you can't execute it. There's no point of having code if it doesn't have effect on the outside world. So we came up with this idea that the core application should have ports to communicate with the outside world. And to those ports, you can plug in multiple adapters. And he goes one step further and he says that there are driving adapters and driven adapters. I really love this thing. And I will explain you why. Because think about the following scenario. I'm not sure if any of you is from UK or another part of the globe where to charge your laptop here in Portugal, you need an adapter, right? We came up with this idea of having adapters to things. You don't need to buy a new laptop because you go to UK or you are from UK and you come to Portugal. Why do you do that thing with software so many times, right? It was basically that realization. But why having one side that is the driving and the other that is the driven? Because all applications are reacting to something, are reacting to web events, point and click, to a console application, and so on. And those are driving adapters. And on the other side, they need to have effect on something, like updating something on a database, writing to the file system, and those will be your driven adapters. Okay, so this idea is really cool, and there's one extra thing that I really love. That is, Alistair came up with an idea that is, every port should have at least 2 adapters. Okay? And why that is important? Because one of the adapters that he says is a testing adapter. So you will come up with an architecture that not only is device independent, but also is really good for testing. That is what we are trying to achieve here today. I tried to do it, and let's be honest, I finally left the lasagna behind, and I came up with perfect raviolis, right? And my ravioli doesn't care of the dressing. It doesn't care of what sauce I'm putting on the plate. It's a ravioli. The meat inside is protected from the outside. But even then, I was finding that my software was not that good so far, because we go after all those trends, but even then there's something missing, and you feel that for sure. And then it comes 2008. Since I work in the Microsoft stack, I perfectly remember a time where every single example by Microsoft was based on Onion architecture. For those who don't know, Onion architecture is basically, the way that I put it is ports and adapters, but with more layers, okay? Because if you look into it, it has the same goals, device independency, but then it's more prescriptive. What Jeffrey Palermo has done is that he will tell you that you need a domain, you need repositories, you need domain services. And when you don't have a lot of experience, having all of that information is really useful for you. So I follow along, but yeah, I keep working on that. Maybe the problem is somewhere else. And then 2009, Mike on a book named Succeeding with Agile, he talks about the testing pyramid. And this was interesting because for those that remember those days, a continuous integration pipeline didn't exist. Your tests run once a day during the night, and you will be lucky if they even start. Your changes will be tested with the changes of everyone else in the company. And we'll go home, and on the next day, we'll realize that everything failed and no one realizes why. So if you have automation testing, that was what we'll be doing, because most of tests at the time were done by QA people, okay? But when we say QA people, we are not saying automation. We are saying, we're going with the mouse, click here, click here, click here, every single day is what they were used to do. The problem with that is when you have one QA person to 8 developers, this doesn't scale, right? So you see where the bottleneck will be. And what Mike realizes is that most of the companies, like the ones that I work for, only invest on automating the part of the tests where you can remove that person from the process. So you know the test scripts of that person, let's try to automate those. And what is this famous testing pyramid that you have heard about it for sure? It basically comes up with this idea. Your test portfolio should have 3 layers, okay? You have unit tests, service tests, UI tests. As far as you go up, your tests start to become really flaky. They will take more time to run. They will take more time to write, okay? As far as you go up, on the other side, you will have an advantage. One single test to an UI component can test multiple things in your base, right? Multiple components. So that's a good thing on the other side. But basically, he was advocating to push as many tests as you can down in the pyramid. But there's a huge problem with this thing. That is, you know the discussion of what is a unit test. And now, if I ask everyone in this room, what's your definition for a service test? I will get maybe 20 different responses for this thing. And now imagine that you have an application that is ingesting just messages from a queue. Do you have UI tests? Not sure. Yes, that's a good one. But many people believe that you should only do it for HTML or things that you can click with Selenium, things like that. So if you go online and you start searching for different alternatives for this pyramid, what we realize is that we as software developers, we think about those things and realize that Mike was completely wrong. He forgot a lot of layers there, and we need more layers to solve those problems. It was not a problem with naming, we just need even more layers. So now, I don't know when to write an API test or an integration test. That was what is happening. Maybe some people are right, and we are not that good with alien technology, and we don't understand a lot about pyramids. Maybe that's the reason. Not sure. Okay, 2012, and Uncle Bob, Robert C. Martin, publishes a thing that he names Clean Architecture. At the time was a blog post that then led to a book. And on that blog post, it talks about one thing, that is this thing, that is the clean architecture, that let me tell you that this is not something new, okay? This is quite famous, but it's nothing new here. Everything that is here, you can get it from ports and adapters, from Onion architecture, from ECV from 1992. What Martin has done was combining all those things in a single proposal. But this proposal has a huge flaw on it, and I will tell you about that in a moment. But there's a really good thing about this thing. As any other thing that you stick the clean prefix, it will be a success. You know, clean code. Can you imagine clean JavaScript? Wouldn't it be awesome? Or even clean regular expressions. I will finally be able to do one. If you look into Google Trends, you can see this thing going up for clean architecture, while hexagonal and onion are not that famous. So on the good side, and why it's important to talk about clean architecture, is that many people are trying to follow along with clean architecture just because it's the most famous one. So it's a good thing to talk about it. Okay, now what I wanted to show you is basically a demonstration of why often we fail on this type of architectures, okay? Why I tried so many times and I was never happy with results. Okay, and I have a video for you. Okay, this is a perfect monolith, let's face it, right? Everyone can agree with that. And now we will see a junior developer approaching the source code. He tries to refactor a single piece, and you know what will happen. Everything will fall apart. You may have a lot of questions now. For example, why such a young person as a developer? It's really difficult to hire. Yeah, we need juniors to start early, maybe. Why this developer is dressed like Elsa from Frozen? That's a good question. It was the pandemic. You were working in pajama pants for sure. So why she couldn't work as a princess? And last question, is she available for hiring? The answer is no, unless you work for Disney, okay? Okay, by the way, she's my daughter, Beatriz. A round of applause for her. Yeah, everyone in the other room should be thinking, oh, hey, thank God I didn't went to that room. It finished so early. Yeah, okay, let's continue. So this is what happens when you try to change one architecture, but you touch a single piece for a simple refactor and everything goes red. You see all your tests going red, or the worst part is when nothing goes red and or you even don't have tests, right? But that happens too often. And that happens because we forgot one part of it, that is testing. Okay? So what do I discover that we can do to reconcile those two, to unify them? And let's start by the architecture. I was telling you that there's a major flaw on this proposal by Robert C. Martin, right? If you look into the colors, you will see all the layers have different colors. This has the same shape as onion architecture from Jeffrey Palermo. But if you look into the Jeffrey Palermo approach, you will see that he only uses 2 colors and he has more layers than this. He uses 2 colors and most of the layers have a label that says application core. Okay? If you go online to see if I'm saying the right thing, just do one thing. Go to exactly the blog where Jeffrey has published this thing. Because there are so many people drawing that onion architecture thing that you will find this mistake on all those architectures as well. For example, this is a common template that we see online for clean architecture, where we are smart people, so if the author says that it should be use cases, we name it application. If the author says it should be entities, we name it domain. Doesn't matter, to be honest. But usually we'll see something like this, where you have, for example, an API or a web application, and on that infrastructure, you stick together everything that connects to databases and so on. If you look into this, I can see only 2 things, to be honest. I can draw a box there that is my internal core, that is the missing thing from the previous diagram. And when I divide this into things, I can map this thing to a ports and adapters diagram. Okay? All that domain and application thing can go inside of core application, and all the green things are my infrastructure, so they are adapters. But I can also say, I can bring to onion architecture that rule of one port to adapters. Okay, as you can see there. Once you come up with this, things start to become really simple in terms of testing, and I will show you how. So my diagram of onion architecture has a different approach. The way that I see it is basically this. You have one important thing that is your core. You can split it in application and domain. Often I see a lot of domain projects that are completely anemic and you don't reuse it anywhere, but you have a project just because. Okay? Just because you are following along. And around it, you can find adapters. The third layer for clean architecture, the name is interface adapters. It's the same concept of adapters at hexagonal architecture. And I split those in 2. I like the idea of having driving adapters, for example, web applications, APIs, message handling, things like that, but also tests. Those are important. The difference between these adapters and the other ones that I will talk about is that these ones know the core application, okay? They can trigger things in the core application. On the other side, you have driven adapters, and those adapters, I can't move myself. I need to go there. Okay, so on the other side, you have databases, file systems, and so on, but you can also have tests there. Okay, you can mock things there as you want. You just respect that contract that you have with your core. Once you get to this, you may think, okay, how do I organize my things? This is a possible approach how I sometimes do it. To be honest, this doesn't matter, okay? Doesn't matter. If you package your application as per service, per layer, everything in one single thing, organized in source folders, Doesn't matter, okay? That doesn't matter at all. If you are building a microservice and you have 10 projects, maybe you are doing something wrong. The important thing is respecting the dependency rule, okay? Is respecting those layers pointing inwards, right? And even more, not even more, but also really important, is following one of the principles for clean architecture, that is a screaming architecture. What is a screaming architecture? It's basically an architecture that you look into the folder structure and you can recognize what this application does. Instead of having names like controllers, services, repositories, and everything sticks together on the same page, you can do things like this. For example, have an import something, add something, remove something, and you will target that functionality. It's a kind of feature-driven approach. By doing this, you start organizing your code better. You can do better refactorings, for example. You will not bring a lot of responsibilities to a single class, right? So the most important thing that you can do, besides following along with a template that has 3 projects and you think that is done, is thinking about the dependency rule, pointing inwards, and then naming things like this, oriented to your approach to the feature. But all of this will lead you to a point where you have a different version of clean architecture. I didn't bring anything really new at this point, but all of that has a reason. And the reason is that your application, if you don't think about how to test it, will fail. In my opinion, you are not a good architect if you don't think how your application will be tested. If you don't think about the cognitive load of writing a test, if you don't think about the friction of writing tests and maintaining it. So if you look into your application and you think that your tests are just a different host for your application, it's like you are deploying 2 things. One for testing, to gaining confidence, and another one to execute your application. Now I need to drink water, and I don't know if I can approach my laptop. Okay, so I will keep alien technology. I believe that if aliens came here to build pyramids, for sure they are on a different point of civilization when compared to us. And maybe the pyramid was a message for developers. One day they will come and they will use this as a testing pyramid. But the difference is that I will say that developer tests, the pyramid is targeting developer tests instead of all tests of your organization. Why? If you work in a company that works with multiple services, microservices, whatever, there are multiple ways to approach those things. And you will find that often you have, for example, end-to-end tests going through all the applications of your company, for example. So I believe that the pyramid should be targeting the experience of a developer working on a single component. And I will name things differently. I will name it unit, integration, and application. And I will explain why in a moment. I keep the same variables, okay? As far as you go up, will happen the same thing. Let's start by the unit. This one is the most problematic one because everyone knows that there are 10,000 different meanings for unit tests. The one that I like to use is the one from Michael Feathers that doesn't explain you what is a unit test, but what is not. Okay? And what Michael will tell you is that a unit test can touch a database, can't go through the network doing something, can't touch the file system, can't go to the environment, whatever. Okay? So a unit test should be something that you can run as a kind of a pure thing. Okay? There's no influence from the outside. And if you look into our application, that looks like the kind of code that you'll put on your core, right? Because your core should be device independent. You shouldn't depend on things from the other sides. So if you unit test this core, you can also use your ports that I told you to write, for example, mocks or fakes, whatever that you want, right? So by doing this, you have a better way to approaching your unit tests. But even then, you can build a really messy thing, okay? For example, you can build something like this. Can you read it on the, yeah? Yeah. I was expecting that you didn't have to suffer like that. But tests like this, where 80% of the code is mocking, this is a huge problem. This is the kind of tests that when someone touches a single piece and everything goes red, it's because of this, okay? If you see one of those, this is a warning flag. This is one of the biggest problems with many tests that you see out there, right? But what we can do? I always recommend to take a look into the test desiderata. I'm not sure if I say this right. Desiderata, I think it should be Italian, I'm not sure. That is a document by Kent Beck and Kelly Sutton. There's also a YouTube series that you can look on it, where they describe a set of principles for good testing. There are a few ones that I really like. For example, structure insensitive. Do you think that all of those mocks are structure insensitive when I'm trying to understand what they are doing, right? They say that it should be behavioral. They should not be looking for, is this component invoked or not? And they should be composable, is also important. There are many more that you can take a look after. And often this happens because the way that I see most developers approaching testing is in a solitary testing way, okay? When you write solitary testing, by the way, there's an awesome blog post by Martin Fowler about solitary testing and sociable tests that you can look online. Basically, solitary testing is when you are testing your system under test, that is that purple box, and you mock everything that it will use, everything, okay? You will make sure that no method outside of that class or that function will be invoked. You mock everything, and then you came up with that thing that I showed you. So every time that you touch that code, you need to refactor your tests. Every time that because of a refactoring, you need to touch your tests, you shouldn't trust your tests. Yeah, it's hard to listen to that, but you shouldn't. What's the alternative? See, is sociable tests, right? It's more collaboration. And you can build sociable tests if you look into your dependencies and you just question. According to Michael Feather's definition of what a unit test is, if I use the real dependency here, will this be a unit test or not? Okay? So if you look into this one, you can think that, for example, this one is maybe a database, is maybe a file system, is maybe an API. But those ones maybe are just mappers. Why I'm mocking them? Why do I want to write extra tests just because of that? Yeah, give it a try. You will see how different it feels once you start doing this. And once you start doing this, you will realize that you often use those exports or public access modifiers just because of testing, right? For example, a mapper from an outside layer like an API to your core application, why should it be public? It's mapping to things from the inside of that core. I don't need it to be public. Are you expecting someone to swap out that mapper one day? I don't think so. Once you start thinking that way, you will just focus on testing public things. When you just focus on testing public things, you will also have less things public, because you want to reduce your contract as much as you can. Why? Let me tell you a story. In the past, I developed an application that generated a ton of code that our clients could use that code for different purpose. And we have there a folder saying something like internal, with a lot of ugly code there, but we forgot to set some things to private. Okay? One day, on a refactoring, a developer thought, we don't need this thing to be public. Let's change it. No one should be using this. This isn't even documented. What happened? From all of our clients, one called complaining. We are breaking something on their system. But they are right. Obviously, we are developers and we say, oh, you shouldn't be doing that. Go say that to one of your most important clients. Yeah, but they are right, that thing was public. And do you know the Ehrum's law? The Ehrum's law tells you that every single behavior that can be observed by the outside of your system is a contract. Think about that every time that you expose a property, every time that you expose a method, every time that you expose anything. Someone may be looking to that thing. They may even infer a given thing just because you are working in a given way. So once you start thinking about this, what will happen is that you reduce the number of tests that you do, you will reduce the number of things that you are concerned, so you will have less friction on maintaining your tests. Okay, enough of unit tests. Let's talk about integration tests. The way that I see integration tests in the context of an architecture that is device independent is that instead of you testing integration tests like I usually see, like you have a test there. Oh, I have an API. Let me call the API. The API will use the application core. The application core will use a database. I test all this thing integrated. Perfect, right? Or for example, I have that web application that is HTML. I don't like Selenium, so I will just do a kind of subcutaneous test. That is when you test one layer below of that thing. You can do it that way as well. The way that I recommend you to do is, do you remember that I told you that you have a contract between your core and the outside world that is a port, right? Why don't you mock your core application? You have a contract to fulfill, is the thing that you have to test, right? You want to test your database, you test your database adapter against the real database. Anyone have test things, for example, they use a SQL Server or a MySQL, and they test against a SQLite. No one used SQLite for testing in the past? I'm the only one. Oh, okay, two friends. Thank you. When you do those kind of things, you are just, I think that you are not really testing the thing. For example, I used that technique for a long time until the moment that I was using Postgres and using a particular function from Postgres that didn't exist on SQLite. So what do? Nowadays, it's really inexpensive to spin up a container, a Docker container, running your real database. And you quickly run your tests, you are happy, you are done, right? So what I recommend you to do is you spin up your container like Postgres. You look into your adapter. Is this adapter doing what it's expected to do according to contract? Yes, perfect, I'm happy with it. That way, every time that you go across your API, core, and database and the test fail, you don't know if the problem is in the adapter or in the core itself. Oh, another example, do you see those ones on the left, like an API? Sometimes you may be testing, for example, if a customer doesn't exist and you call the API with a given ID that doesn't exist, you return a 404, let's say, right? Why don't you mock your core application and you say, I want you to return a null or a monad, because we have Mark Simon here. Thanks, Mark. You want to return a monad saying, okay, this is an optional value. If it doesn't exist, I will say it doesn't exist. So why don't you mock that way? And you just test, if you call your controller, it returns what you are expecting. You don't need all that burden of going back and forth. Right? So, but maybe some of you are thinking, yeah, but that way I'm not checking if the adapter works with my application. And that is true. That is why I say that you should have application tests. But there's a good news on that. You maybe already have it, because most systems already have any kind of end-to-end tests, functional tests, acceptance tests, you name it. It's something that tests the real application with the dependencies in place and makes sure that everything boots up. For example, since I've learned TDD, sometimes I feel too confident and I don't even start the debugger. I'm that kind of person. So I write my unit tests, I'm happy with it, and I send it to QA. What happens? Someone that will test it on QA, check that I didn't inject the dependency. Sometimes those things happen, right? If you have your application test, that is some kind of thing that runs everything and just do a kind of a smoke test that everything is wired up correctly, you will avoid those things. But what I described to you was a way to look into that pyramid in a different way, more prescriptive, I would say, trying to unify with domain-centric architectures. But what I didn't told you about is that that is not enough. I can give you a good example. I have here my friend Sergio, for example, and Sergio, let's imagine that he brought a new car and he subscribed a good insurance for his car. Okay? Today, he received a proposal of a new insurance plan that has extra coverage, okay? Something because of wildfires, let's say. And the price is even slower, is smaller. What Sergio should do? Should he subscribe the new insurance plan and cancel the other one? Or should he keep both? Option A, right? Shouldn't cancel the other one, otherwise he will be paying twice. So why the hell do we keep multiple tests testing the same thing? What I see so many times is that you have a feature to accomplish, and instead of looking into the test that you have and seeing, oh, this test should be updated, there's an extra assert that you should be doing there, for example. Or let me test this thing, but only assert this new thing. What we do is that we copy the original test, and we add an extra line. Isn't that brilliant? Because it feels so strange to delete a thing that is supposed to be good. We are always proud to say we have 10,000 tests. Yeah. That's not a motive to be proud. You should reduce your tests as much as you can. Yeah? That is the sunk cost fallacy, is when you feel that your investment on something can't be lost. And you feel that thing is good, so you don't want to remove it. So always look into tests in a way that you can maintain them. Another thing that you can do is always try to optimize and deduplicate. The end goal of a pyramid is basically you want to make it efficient. Okay? You want to have confidence, but needs to be efficient. So, for example, every time that you spot a test going red on your application test, the upper layer, end-to-end test, acceptance test, whatever you name it, look into the other tests and see if something is red as well. If it's not, it's a good opportunity for improvement. Okay? Maybe that assert is something that is missing on other place. And on that case, just push it down, see it going red, fix the bug, or whatever. Sometimes you may not be able to do it because it's, in fact, a problem with wiring up of everything, but those cases are really rare. Okay, so we went through all this thing, and I really believe that this is helpful because anyone here remembers the Flash ban by Apple? If you don't even remember what Flash is, the best way to describe it is like if your website has a lot of TikTok videos built by a 8-year-old graphic designer, okay? A lot of flashy things, a lot of colors, and you want to close everything. At the time, in 2010, most of sites have some kind of Flash there, or they were all built with Flash. And Flash was really a pain because everyone struggled with it. You need to reinstall it multiple times. Your Windows and Mac will fail because of that. So one person, I don't know if you know his name, is Steve Jobs. At the time, no one gave him a lot of value by that, but in fact, he has done a good thing for the industry. The problem is that a lot of companies that were investing on another good technologies that follow the same model of having a plugin in your browser suffered with it as well. A lot of companies were following the lead by Microsoft on Silverlight, and all the investment was lost. Many of them just stopped building that product because they need to go back to the beginning. Yeah? And what I believe is that if at the time those companies have an architecture where Silverlight, for example, is just a plugin to their core, and they have proper testing on their core application, they will move really fast to HTML5. Okay? And what you don't want is that once we have another Flash pen, the new thing, you don't want to be on that place, I assure you. So what I expect is that I gave you a simple way to look into your architecture, but without forgetting that that thing needs to really be really good to testing. The cognitive load required to writing a test should be really small. Your developers shouldn't even ask you where they should write that test. Okay? It's 2 paragraphs on a wiki page saying, this is this kind of test, this is this kind of test, this is this kind of test. Okay? Should be no different things that are difficult to decide. And to do that is quite simple. You just start by your core application. Okay? You focus on your really important things. You delay decisions to the future. Okay? You may think that it's a good idea to have a DynamoDB database, a Postgres, a Cosmos DB, whatever, but don't start doing it until you are sure of what you want on your application core. Okay? When I say start by application core, obviously I don't say write all of your application core and then move on to the next phase. Do it in small cycles. But start with your application core and write unit tests around them. Don't forget to follow those rules. Write tests in public. Write sociable tests. Write tests that are easy to maintain. Write less tests, let's say. Then you implement your adapters. Okay, I want to use an API. Let me write an adapter for that. I want to use a console application. Let me write an adapter for that. I want to write SQL database. Write an adapter for that. And test those in isolation as an integration test. And then you will combine everything, everyone will be happy, and you start the application to make sure that everything is okay. This is the most important slide that I have on all this presentation, okay? I'm proud of it. Then if you print it and you send me, I can sign it, okay? No problem with that. Okay, so this is the strategy that I recommend. The good thing about this is that you can apply this to any kind of domain-centric architecture. It doesn't matter if it is clean architecture, ports and adapters, onion, you name it. You have the dependency rule pointing inwards, you can do this. Okay? It's that simple. And this has a huge impact. You will see it. Okay. I hope that I gave you a framework to simplify, and I hope that you liked it. Okay? Thank you all. We have a few minutes for questions. If anyone has any question, yeah, sure. Yeah. So the question is basically, for example, in a domain-driven design way, where you have an aggregate, that aggregate has entities inside, how should we approach that? Am I right? Right. Okay, so on my opinion, when you go, let's go back on the slides. Here, that aggregate will be inside of this thing, okay? Once this person, by the way, what's your name? I don't know how to say your name. For sure, you don't know how to say mine as well. Okay, so when he tries to build something like that, I can assure you that he has a strong domain model. He was thinking already about decomposing in aggregates, entities, and so on. The way that I see that you should do it is through your aggregate. That is the most important unit of logic of that system. Doesn't mean that if your entity is exposed to the outside and the outside world can use it, you shouldn't test it. You should. Because every time that something leaks its public to the outside of one of those concentric layers, you need to think that it doesn't matter if it's a service from your team. Doesn't matter. Anyone one day may depend on that thing. And on that case, I want to be sure that that thing is good. So if you have logic inside of that entity, I will test it as well. Okay, I don't know if I answered your question. Yeah, kind of. We can chat after maybe in the concrete example. Any other question? No? On that case, thank you all for coming, okay? And see you around. Bye-bye.